let's just begin by reviewing, okay? Firstly, what do I mean by standard integrals? I hope by now you've seen that during the HSC you get, generally on the back of your 2-unit and extension 1 and 4-unit papers, excuse me, a little table, and all it's got is maybe 10 or 12 integrals that you're sort of expected to know, but they give them to you for free, okay? So things like, let's see, the integral of x to the n with respect to x is equal to, you can give it to me, can't you? This is integrating, right? So what do? Okay, good, power goes up, and then you divide by the new power, right? Plus your constant with one exception. What's the exception to this rule? M cannot be. Now why would that be the case? Why can't it be that? Right, okay, because if you have 1 over x here, right, you don't use this rule at all. The integral of 1 on x is log x, isn't it? We've just been looking at that, okay? So anyway, you've got these, there's a few there, but really you shouldn't need to look at the table of standard integrals, okay? Because these are the kinds of ones which you've been doing for a long time. What we're talking about is the integrals that don't belong there, okay? Warning. So, for instance, we know this, right? This is a simple one. It's on the, actually if I chuck an A in there, you do know that's on the table of standard integrals. Just quickly, just like before, what is the integral equal to? There's some division happening, isn't there? Because when we differentiate it, go the other way, right? Chain rule tells you have to multiply by the 2 of that inside function, which in this case is A. The 1 on A cancels out, and that's what you end up with, okay? Plus your constant, okay? But we've looked at yesterday how you might approach a question like this. Okay, this is the specific example we used, actually. It's not a standard integral. How did we do it? What trick did we use to get this value? Now you got 2 sort of approaches, right? I think sort of the trickier one is the one that the textbook uses. The textbook says, look, 2, you can express that as base e with some other stuff in the index. How do we express 2? Do you remember? E to the power of log 2, so that's 2, right? And then you go to the power of x, and then off you go, okay? But the other method of doing it is to remember that 2 to the x, we actually know a fair bit about 2 to the x, right? We know that if we started with 2 to the x as our primitive, right, and you differentiate, then you get a very familiar result. Do you remember what it was? 2 to the x log 2. We sort of developed that result by limits, yeah? Okay, now, excuse me. Do you remember what we did from this point? We said, well, okay, if you differentiate this and you get here, if you integrate this, you ought to be able to go back, okay? So all you need to do is shuffle around a little bit. In this case, divide by log 2. And that'll get you what you want on the right-hand side. Now I can just integrate everything with respect to x, and that gave us our, over here, that gave us our result, 1 over log 2, 2 to the x plus your constant. Okay, so this idea here, this is what I'm trying to go after, that you can meet an integral that you don't know how to integrate. It isn't part of the things you're expected to know, okay? But you can use this differentiation trick to get something similar enough that you can work it out. This happens all the time, okay? So as well as being called non-standard integrals, these are often named differentiate, hence integrate. That's kind of the name of the question. They follow a very specific pattern of the HSC, okay? So let me give you a classic example. It's in 13C, okay? And if you haven't done this already, you want to do this example now. Differentiate x e to the x, okay? And then I think they say, hence, integrate x e to the x. I think that's the question, okay? Who's done it already? Anyone? Yeah, good, excellent. About half of you, right. So, for those of you, just make sure you're setting out okay on this. For the rest of you, how would you go about this? Now, the reason why they have to give you this clue is because x e to the x is a product, right? And we don't really have a, we've got product rule, A chain rule, you got reverse chain rule. We don't really have reverse product rule, do we? Okay. Hence the need for this kind of trick. Yeah. So let's give this a go. Let's follow their steps. So they've said differentiate x e to the x. Right. It's just a product. U there, v there. What are you going to write? X. X, wait, is that it? Wow, this is a much simpler derivative than I thought it was. Okay, hold on, how does product rule go? You go u, v dash, right? So in this case, v dash is just, yeah, okay, good, right? So there's 1/2, what's the other half? Plus 1 times, okay, good. That's u dash v. Fantastic, okay? Let's just tidy that up a little bit. Okay, now, I'm going to keep that left-hand side there because I walked you through this step over here of how I rearrange, okay? What am I after? I'm after the integral of this, okay? So, in a second, I'm going to integrate everything with respect to x, okay? But before I do that, I want to do a bit of rearranging. I want to get this guy on its own. So what should I do? Okay, so I'll subtract this e to the x, okay? At the same time, since I want the integral of this to be the subject, I might as well move that over here. So I'll do that. Okay. Now, being that I've just integrated, okay, I have to integrate everything else as well. Okay. So when I integrate this, what should I expect to get? Just x e to the x. I just go back where I came from, right? Plus a constant. Yes. Okay. Now, hold on a second. What did I do? I moved this guy over here. So he's actually a negative now, right? And I have to integrate him. Okay, is that alright? Now, by the way, no Mark is going to lose sleep over this, and you shouldn't either. But in a second, I'm going to have another constant flying around, okay? So for now, I'm going to say this c, when I introduce it, I really ought to say, what is it? It's an arbitrary real number, okay? So that's why I write this on the side. Now I can integrate. Now, this thing on the left-hand side, I don't need to integrate because that's the question. Yeah. So I'll just leave her there. That's already accounted for. That's fine. What's this? It's just in the x, isn't it? Now, most of you, 95% of you, will just leave that as c. Okay. It's just sort of okay because it's still an arbitrary constant. The thing is, you're the top class, higher standards, okay? These two constants, they may be the same, but more than likely they're not, okay? So really we ought to call it something else, yeah? Now, like I said, no one's going to lose any sleep over that. I doubt you'd lose any marks, but it's not right to have the same constant appear. It's just like, I'm just going to lump them in together, whatever, constants. How discriminatory of you. They're real numbers. Get it? Real, anyway, sorry. Alright, so do you see what I did? You start off with the clue they give you, but you need to do some shuffling before you can get to what you want. Okay? Alright.